Is a supernova really the only way a massive star can die? When massive stars reach the end of their lives, we usually expect them to explode in a supernova, one of the most energetic events in the universe. This happens when the core of the star collapses under gravity, triggering a powerful outer explosion that ejects the outer layers into space. In most cases, what remains after this process is either a neutron star or a black hole. However, recent observations published in February 2026 suggest that this may not always happen. Astronomers studying a star in the Andromeda Galaxy observed something unexpected. Instead of exploding, the star gradually became brighter and then faded from view entirely. There was no clear supernova, no sudden release of material, and no visible shockwave, only a steady disappearance. The most likely explanation is that the star underwent what is known as a failed supernova. In this case, the core still collapses, but the energy produced is not enough to push the outer layers outward, so they fall inward instead. As a result, the star collapses directly into a black hole without producing a visible explosion. This matters because it challenges the idea that black holes usually form through observable supernova events. If some black holes form in this quiet way, it suggests that there may be many more black holes in the universe than we have detected so far, simply because we rely on visible signals to find them. It also raises an important question about the physics involved in the stellar collapse. The final outcome seems to depend on a combination of factors, including the star's mass, internal structure, rotation, and possibly magnetic fields, but current models do not fully explain why some stars explode and others do not. Observations like this are important because they give us real data to test and improve those models. This also shows that even processes we think we understand can behave in unexpected ways when we observe them closely. If stars can collapse and effectively vanish without a trace, then a significant number of black holes may have formed in this way, remaining undetected. Understanding how often this happens could change our estimates of how many black holes exist and how they are spread across galaxies. In the end, this is a good example of how new observations can challenge existing theories, and why astrophysics is still an active and developing field of research. This has been episode 1 of Biggest Mysteries in Astrophysics, a new series for 2026 exploring the biggest unanswered questions at the frontier of our universe. Next time, we go even deeper. Stay tuned because we're only just getting started.